INSEE is a proud member of the Siam City Cement Group Public Limited, a leading cement manufacturer in Southeast Asia. The Siam City Cement Group provides world-class construction materials to a host of countries around the world. This includes Cambodia, Bangladesh, Vietnam, Thailand, Indonesia and Sri Lanka. With a plethora of landmarks and buildings that define the skylines of these countries, the Siam Cement Group pledges to be a role model in corporate governance and sustainable development. INSEE Cement, Sri Lanka's premier cement manufacturer, is the brand behind our country's leading cement products and the driving force behind making Sri Lanka more sustainable. With a reputation built on outstanding performance in the quality of our products, unparalleled customer service, the dedication of our employees, our respect for the communities in which we operate, and our ambition to set the standards for the industry of tomorrow, we have contributed to the growth of Sri Lanka with iconic developments across the island. Just to name a few: the Lotus Tower, Altea Residencies, the Colombo South Harbour, Southern Expressway, Mattala Airport, the Kalladi Bridge, the Kotalavala Defence University, Mahinda Rajapaksa International Cricket Stadium. INSEE has cemented its position as the most preferred local manufacturer of cement in Sri Lanka, with its widespread distribution network comprised of over 7,000 dealers in retail segment located island-wide. Today, we have 2 plants in Puttalam and Galle and 2 terminals in Galle and Colombo. INSEE's Sunstar brand is Sri Lanka's first cement product to be awarded the Green Labelling certification by the Green Building Council and was the first blended cement to launch in Sri Lanka. INSEE has a wide portfolio of cements and services to suit all your construction needs. The most popular among them: INSEE Sunstar, INSEE Mahavalley Marine Plus, INSEE Extra for mass pouring concrete, INSEE Rapid Flow Plus, INSEE EcoCycle, INSEE Concrete, Convert by INSEE, state-of-the-art innovation and development facility. Having been a part of Sri Lanka for almost a decade, we will continue to build on our long heritage of shared loyalty, creating trusting relationships with our business partners, people and community, and delivering our promise of building the nation.
Followed by this session, this knowledge sharing session will be followed by a panel discussion. The panel discussion will be moderated by Engineer Nandana Munuthudur, while the participants will be, the panel members will be Engineer Udayanga Alvis, Engineer R.M. Abesinghe, and Engineer Pivithiri Chaisinghe. So, let me invite Mr. Jan Koenig to address the gathering to give the welcome note to today's knowledge sharing webinar session. Mr. Jan Koenig is the Executive Vice President and Commercial Director, Marketing, Sales and Innovation for INSEE Cement. Jan, over to you to address the gathering and to welcome our guests today.
Thank you, Susan. I hope you can hear me, everyone. Good afternoon, good evening to everyone. As you can see, I'm currently not at my own laptop because I had some technical difficulties, but Nandana, I'm representing Nandana, so I'm fine with that. Very warm welcome, everyone, to this INSEE Eye-to-Eye knowledge sharing session today again in a webinar. As all of us know, the situation in Sri Lanka is mixed, let's call it this way, but I'm convinced that Sri Lanka as a country will come out of that quite soon. Let me first say a big thank you to Mr. William Chang, Senior Chief Civil Engineer of Power Far East Group, to join today, and also to Engineer Udayanga Alvis and Engineer Abesinghe and Engineer Jayasinghe for being with us in the panel. Today's session is a session in 2 parts. Today we start with modern construction practices in board pile, second pile and diaphragm wall constructions. I personally have worked with the Bauer Group in Germany back and in Europe, but also in Indonesia, where I was working for Holcim earlier. So we have Bauer Group as well in Sri Lanka, and we have had significant project engagement and experience where Mr. William Chang will also give us some inputs on project. For those of you who do not know the Bauer Group, Bauer Machinery GmbH is a German company since the 1960s, and since the early 80s already in Asia, with a hub from Malaysia, producing specific machineries for whether it's drilling rigs or foundation cranes or diaphragm wall equipment. So really specialized in the construction. And if we see the important projects which are on the horizon for Sri Lanka, then for sure piling is critical. And also we know more and more is being a vertical structure, for example, high-rise, then also in certain of the marshy lands in Sri Lanka, this is getting even more relevant. So thank you very much for this cooperation from Malaysia with William Chang. William, sincere thank you for making yourself available. Very much appreciated. It's now actually the third webinar where we have international guests as well and speakers. So very much appreciated. And we work together in many our markets. In SE and Bauer are also very successful with modern cement and concrete types on the best projects. So I wish all of us a very good session. Thank you very much. And also to the panelists, looking forward to an interesting panel discussion thereafter. Thank you very much.
Thank you.
Thank you, Jan. Thank you, Mr. Jan Koenig, Executive Vice President and Commercial Director, Marketing, Sales and Innovation for NC Cement. Today, the session, the theme will be modern construction practices in board pile, secant pile, and diaphragm wall constructions. This session is organized by and as an initiative of INSEE Eye-to-Eye collaborative space. This knowledge sharing webinar session and the panel discussion for November 2020 is the 21st knowledge sharing session organized by Innovation to Industry Eye-to-Eye of INSEE Cement. Ladies and gentlemen, dear friends, before I invite Mr. William Chang to conduct his session, I would like to mention whatever the questions, queries that you have on the topic, on the subject, on the presentation that Mr. William Chang is doing, you can type it in the Q&A section, which is arranged in this Zoom panel. Let me present Mr. William Chang. Mr. William Chang is the Chief Senior Civil Engineer for Bauer Far East Group. When we present the project engagement and experience of Mr. William Chang, we are very happy to mention that he has experience in Sri Lanka too. China-Shanghai Deep Shaft Link, Canada Falcon Project, Sri Lanka ITC's Tower Diaphragm Wall Project, Malaysia Medaka Tower Bow Pile and Diaphragm Wall Project, Malaysia Oxley Tower Piling Project, Sri Lanka Madampitia Secant Pile Wall Project, China Nianjing MRT Line 7 Secant Pile Wall Project. These are some of the projects that Mr. William Chang has participated, has contributed to in his capacity. Mr. William Chang, the Chief Senior Civil Engineer for Bauer Far East Group. Sir, may I invite you to address the gathering and to present your session, the presentation. Today, the session will be on modern construction practices in board pile, secant pile, and diaphragm wall construction. Mr. William, over to you.
Okay. So I start my presentation here. Today, my presentation will separate into two portions. Can everybody hear me? Then first beginning, I will start from the board pile. Okay, the first beginning, I will spend some time, few minutes to introduce our company. So the first start from 1790, the Bauer start beginning as a coppersmith in Schopenhausen. Then later on from the coppersmith, they work to the brewery, to the water supply, to the water well, then go for the deeper hole drilling, and then they become a foundation business. This is 1960 in Schopenhausen, Germany. It's a Bauer headquarters at that time. You can see a car parking in front. The left-hand side, the bigger one, the car of the boss. The right-hand side is the car of the project manager. So nowadays, power become a worldwide network. So we have more than 110 subsidiaries in about 70 countries. Then we have a few major product plant, like we have our headquarters, Schubbenhausen, have a production. In KL, we have a workshop here. In Tianjin, we have a plant for the value line machine. In Conroe, we have some other equipment made in US. Then we have more than 11,000 employees around the world in 81 nationalities. I think 40% of them in Asia. So we have a 3 segment of our power group. It's a construction and the equipment is what I'm working for, and also the power resource. So the power group start from 1980 all the way come to 2018. The revenue of company of the group go up to 1.8 billion US dollar. It's a long-standing healthy business development. So this few our workshop in Schubbenhausen, in Arasing, Edhausen, and we have some our subsidiary company, the daughter company like Prokla, Eurodrill, Clam, Schackbau, and also Matt in Germany. And then we have other facility in Shanghai, in KL, in US, in Italy, and also Tianjin and Russia. So these are power AAA policy. Okay, that's my introduction for the power group. Then we come into our topic today. So the agenda today for the ball pile system will be the reason why we select the ball pile system. The second will be the partly case pile. We also call it slurry pile. The third one will be the rock drilling, because we know the Sri Lanka, especially in Colombo area, you go down to 20 meter, 25 meter, sure you get a very hard granite there. Number 4 will be some extra large partly case pile project. And number 5, we'll go into the fully case pile and also second pile wall. So let's start. The first, why we select the ball pile system. The ball pile foundation has been widely used. So something you can see on the picture, left-hand side is a skyscraper. The right side is like an infrastructure, the big bridge, highway, or the high-speed railway, or the road bridge. We all use the ball pile foundation because it's suitable for all kind of a soil condition, no matter the soft soil, unstable soil, dense or cement soil, or even a rock, and very flexible for the application. The diameter from 600 millimeter up to 3 meter diameter. The depth can from 20 meter down to 100 meter. And then the machine is very compact. We don't need too much space. It's very helpful in a congested urban area. No vibration during the pile installation. The noise level also pretty low. And the load transfer for the pile, transfer in the friction of the shaft and also the end bearing, and transfer very high vertical load, tall building, a massive industrial complex, the piers of the bridge, then transfer capacity up to several thousand tons. The high resistance of the horizontal load, if the pile bigger than 800 millimeter, is a very mature system for the technically, from the design, from the equipment, from experienced contractors. So this is a high-rise building, for example, on the top. You can see a lot of ball pile at the bottom of the building. So the load will transfer into the ground by the pile from the shaft friction and also the end bearing if we hit the rock. So this BG system, we have many applications can be used. Each of the icon can have 1 hour topic to present to you. But today we have to select a little bit less. So we focusing on the KD drilling, and this for our BG value line machine, but premium line also can do the work. So the ball pipe system, we simply divide into two. The intermittent system means the KD bar system, we drill down and up all the time to bring up the soil discharge, then go back again for the drilling. So we call it the intermittent system. The right hand side, we can see the single pass system. There's a CFA system, FTP system. They are typical for the single pass system. The pipe will work like this, like a CFA. He will drill down to the design depths. In the same time, when we withdraw the CFA, we will jet in the cement mortar. Then later, we go install the rebar cage. So it means the CFA fly auger only go into the soil once. So we call it the single pass system. So today, we're focusing on the KD drilling system. So we talk about the BG. We have a few main components. The base carrier. On the crawler, we have an engine, have a hydraulic power on the base machine. Then we have a mast. We need to handling the long KD bar. We also need to resist the torque and also the tension. Then we have a KTK to provide the torque to the drilling tools. Then we have KD bar and drilling tools. Then we have a winch to operate this KD bar and tools up and down. And then we have a control system. It's controlled by electronic and hydraulic. Then we have a product into two lines, premium line and value line. Premium line, as I say, can do everything. It's multi-purpose machine. But the value line is more for the KD drilling. So this is our product range for our value line. 6 model from smallest BG15H to the BG38. So we go to our second topic, the partly case pile, or we call it slurry pile. So I try to simplify this the piling system. For the fully case pile, the diameter may be limited within a 1.5 meter diameter. The depth will down to 45 meter. The slurry piles, the partly case pile, we can drill up to 3 meter diameter, 100 meter deep. So the main construction step of a partly case pile. So we install a standing pipe and drill down to the final depth with the slurry support. For the installed casing, we can use the BG with a casing drive adapter. We consider the casing should be installed in a certain stable depth. For example, for the cohesive soil, if the SPDM value above 5, we consider it stable. If a non-cohesive soil means sandy material, the SPD should above 10. The left-hand side is a picture of a BG40 with a 14-meter long casing in Bangkok. He installed the casing in once, and also popular using top vibro to drive the casing into the desired depth. So later on, we drill to the required depth. And some of you maybe do not understand why the KD bar looks the machine only 20-25 meter long, and how to drill 100 meter deep. I can show you a small animation here. So the KD bar lower down, it actually like a telescope fishing rod. So I have a section by section. So once you go into the certain section, the KD will turn and go into the locking position, can still provide the drilling ground force and torque to the bucket. Then we pump in the slurry to stabilize the borehole. So this is the concept while we're drilling. The outside the shaft, we have water pressure below the groundwater table, and also we have the earth pressure as well. Inside, we have to maintain a higher bentonite level above the underground water table, and also the density of a slurry will be higher than the water, so we have a slurry pressure to balance the shaft, so we can continue drilling until the depth we need. So this will, when we finish drilling, we're recycling the pile to separate the sand content inside the slurry. Then later on, when the pile slurry getting clean, we're going down with the rebar cage. Yeah, this is the rebar cage for the pile. And then we concrete. So after concrete finish, we dismantle the trimming pipe and also withdraw the casing. So this is the trimming concreting step. For example, now inside the pile is a slurry. So we install the rebar cage and also the trimming pipe with a rubber bowl. Once we pull in the concrete from mixing truck, the concrete will push down all the way down to the bottom through the end of the trimming pipe going up. And the finished concrete, take out the trimming pipe, then we throw the casing. So for the quality aspect, so we have a lot of things that need to monitoring from the material. We need to take care for the reinforcement, take care of the concrete. We have to take care of the bentonite during the drilling or before we put the rebar cage inside. For the drilling work execution, we need to take care for the verticality of the drilling and also the shaft continuity. The rig, we have to take care for the maintenance and make sure the teeth on the tools is proper install and proper maintenance, and also the assistance system. The number 3 will be the rock drilling. So the advantage of the rotary drilling rig for the bore pile, we allow to drill big diameter above 3 meters. We can achieve a very deep depth, more than 100 meters. It's a high production and allow to change the right drilling tools rapidly according to different soil conditions. With only 2 pins, take out the pin, put the pin back. I think change the tools about 3 to 5 minutes. We can have a lot of different drilling tools for different kind of soil conditions. So refer to the soil condition. We need to know what we deal with. Is a dry hole drilling or slurry pile? If the dry hole, we may go for the auger. The slurry pile, we should avoid to use the auger. We have to go for the bucket. Is a cohesive soil or non-cohesive soil? Cohesive soil means the clay. We need to have a better flat-tip system. A non-cohesive, we may use the bulletis. So and also if we have a rock, what kind of a rock? Is a granite or limestone or sandstone, and the condition of the rock and also the strength. So for the tool selection, from the rock strength on the top, you can see from 5 MPa, we still can use the flatties. Until 100 MPa, we use the bulletis with a different setup on the different tools with a coal barrel or the rock auger. This is some example of a rock drilling. It's an MPG-12 in Scotland, 10 meter deep, diameter not big, only 520 mm. Kelly system is drilling very hard rock. Basalt is from the volcano. So the strength up to 112 MPa, but he only using one progressive rock auger. He can achieve 4 piles a day, every day working 12 hours. So how the Roentgen chisel break into the rock? We need a V, is a crowd force from the machine, the torque M from the KDK. So these two forces combined together will help the Roentgen chisel going to break into the rock. This is another sample, MPG-24 in Ireland. The drilling depth 10 meter, drilling diameter 750. It's a limestone. The rock strength 90 to 120. They use a progressive rock auger and also core barrel. Then list how the core barrel working. Is cutting the ring outside of the core, release the lateral support, isolate the rock core, and we have a very good chance we can break this core and bring out. If not, we have to destroy with a rock auger or the rock bucket if necessary. So this is a rock core we taken out. Another example is in Shanxi BG25C in China, 30-meter deep, 1.5-meter diameter. It's the same stone, not so strong, 20 to 50 MPa. They're using rock auger, rock bucket and a core barrel. In another case in Jiangxi, China, it's a limestone, 50 to 100 MPa, rock bucket, core barrel. So this is also in Guiyang, China. It's 1.8-meter diameter limestone. So above, we see few cases, the rock strength above 100 MPa already. The ordinary core barrel and the rock bucket still able to perform. But how about the teeth consumption and the penetration rate? Are those still in a reasonable range? This we have to consider. Then above 400 MPa, normally practice, we will go for the roller bit. So this standard roller bit core barrel, we don't use the bullet teeth anymore. We use the roller bit core barrel. It's also very popular in Southeast Asia for the hard rock drilling project. So this the first testing in 2012 in China. We introduced this roller bit core barrel into China market. Left-hand side is our operator. Right-hand side is a project. The equipment boss. So this is our happy power salesman after the test. Really good result. You can see all the granite core line up. So this is the power thing on site. And the rock strength testing result from 136 MPa to 148 MPa. Then these few other roller bit core barrel testing and also the practice on site. This one is a BG46 in KL 2013. The diameter 2 meter, 2.2 meter. The pile depth is pretty deep, 90 to 103 meter limestone. It's right beside the KLCC. This is the project when the roller bit core barrel new delivery to site. We can notice that is a roller bit is no more welding only. So it's with a holder on it. We can exchange the roller bit when it damaged or need to be replaced. You just put in with a 2-pin. Make sure the roller will be the same position. This is another testing, a little bit smaller roller bit core barrel, 1160, also holder type. You can see the setup of this roller bit core barrel. This one is another one, 2015, also in KL, 2150 millimeter diameter. It's a little bit bigger size and also bigger machine with a BG46, and they're using a 12-inch roller. Normally we use a 8.5-inch roller, but this one using 12-inch roller. So this is another project recently, 2018. They have many roller bit core barrel on site from 2.2 meter, 2 meter, 1.8 meter, 1.5 meter, and 1 meter. And this is the happy face of the boss of the equipment owner and also his manager team. And the new development of this year, we using the bolter type. So the roller bit is no longer with the pin. We're using 2 bolts fixing from the bottom. They will also have some advantage, and we're still under testing. Also rock drilling in granite. So some extra large partly case pile project. So this one of that, 2016, beside the KLCC extension. They have 2 big machine, BG48. The operation weight up to 270 ton and 1 BG46 with a 5-section 120 meter long Kelly. The depth of the pile they finished 90 to 110 meter, diameter 2 meter to 2.2. So slightly bigger in 2017 with a BG50. We have a Kelly bar 4-section 100 meter and a 5-section 120 meter. If I remember correct, this 120 meter Kelly bar itself already 30 ton and 30 meter long. So the operation weight will be 290 ton. The diameter 2.8 to 3 meter. The depth down to 110 meter. So this the size give you impress. The right hand side is the BG40. As I know, the biggest machine in Sri Lanka is a BG30 or BG36 or BG39. So roughly the same size as the BG40. So left hand side is the BG50. You can see the size different. This is our biggest power drilling rig, BG72, with longest Kelly bar power ever built, also in KL area, Tower M. The 5-section 150 meter Kelly bar is allowed to drill down to 150 meter. So the Kelly bar itself is more than 40 ton. The length will be 36 meter long for the transportation. So operation weight of this machine altogether more than 300 ton. The pile diameter 2.5 meter. So the depth, the deepest one they finish is 126 meter. So we jump to our fully cased pile and the second pile wall section. So the main construction step is a little bit different than the partly cased pile because it's fully cased. The first beginning, we drill down to the soil with the casing and the drilling tools together. The second, we drill and rotary the tools, bucket, auger, or whatever the drilling tools called barrel. And we stabilize the borehole, no longer using slurry, but with the steel casing. Then later, we don't need to descending because no slurry. We just put the rebar cage inside. And then we concreting with the trimming system. Then we restore the casing section by section. So I go to the second pile wall because second pile wall, every individual pile is fully cased. So we talk about the fully cased pile. We can talk about the second pile wall together. So they will have normally 4 types of different second pile wall. So the type A is the most popular one. We have a concrete second pile wall, and every second pile is reinforced. The reinforced pile, we call it secondary pile. The one without the reinforcement, we call it primary pile. The B, no matter primary or secondary, always the reinforcement, but you can see some square rectangular shape of a rebar cage. That's a primary pile. Then we have to avoid the casing cutting into the rebar, so we make the rebar cage the rectangular shape. C is the partly reinforced soft hard wall. The primary pile will replace by the soil mixing or grouting. It's no longer with a fully cased primary pile. Then number 4, we install the H-bin inside the soil mixing or grouting pile. So for the second pile wall, it's also same for the fully cased pile. It's a 2 key points to make a quality control of the second pile wall. The first, we have to positioning the pile to ensure the overcut precisely, and also the location of the pile have to be very precisely. Second is the vertical of every individual pile. So the first one, for the positioning, we need to build up proper guide wall. The second, we need to control when we install the casing, for the casing verticality. We need to check all the time. So this is the typical layout for the guide wall. So the diameter of your second pile wall, for example, AAT, the D here will be the diameter of the guide wall will be 900 plus 20 millimeter. So this is the typical one. We're using a plywood to build up a formwork for the guide wall of a second pile wall. So this will how it look like. It's all the curve. Every pile location will be very clear to find out. The sequence for drilling, we drill, the yellow one is a cased primary pile. So in the between, we drill the secondary pile. So it's how the secondary pile overcut into the concrete of the primary pile concrete. So it's a casing in a blue color with a casing shoes with a tungsten carbide on it. We can cut through the concrete. In the center, we're using the auger to drilling. This is the project testing in Shanghai, China. We have both primary panel and secondary panel with a rebar cage. I think this pile was one section casing drilled down to the secondary pile. I have asked them to bring out the casing and show them the surface of this the drilling surface. So you can see on the left hand side picture, on the top, the yellow part is the soil, the clay, and left and right, it's very clear. You can see the concrete. Even the white color is a spacer, the PVC pipe. With a rectangular rebar cage, we try to fix the location of the rebar cage in the casing during the concreting, not moving anywhere else. So we put the left and right PVC pipe as a spacer. So you can see the secondary pile really overcut into the left and right. So the second pile will have some advantage. We can follow in the rock level. We also can depend on the load different. We can have a deeper socketing length or less socketing length. For the excavation of the second pile wall, the inside here is the excavation level. Here, blue color is our second pile wall. So outside of the second pile wall, we have a soil pressure. Then we have underground water pressure. The inside, we have also underground water pressure and also the soil pressure, right? So during the excavation, for the strength of second pile wall itself may not enough. So we need the extra strut or the anchors to support during the excavation. For the utility problem, we can solve by the second pile wall system. And also finishing of the second pile wall, we can use the shotcrete or the RC wall or structural wall. Then can be part of the structure as well. We can put the rebar cage inside the secondary pile rebar cage, and we open that and bend out, connect with our structure, or we just simply install the reinforcement with the epoxy. It's a really watertight retaining structure. You can see it's about 35 years ago. Power built up this Tigris bridge, the caisson of that. You see the second pile wall construct on the top of a river and very dry and clean inside. This is another project in Munich. A small river runs through beside. You see all the excavation pit of the second pile wall really dry and nice. Using 4 layers of anchor, it drill down to excavation down to 25 meters. In the center pile, even down to 30 meters. Still watertight. So it's another project in Australia. You can see the anchor they use. For the smaller pile, normally is a primary pile, soft pile. The bigger one is the secondary pile. So this in Taipei, Taiwan. They're using strut. So it's another project in Cambodia, Phnom Penh. So as I say, I've been to Sri Lanka working long ago. This first project, I went to Sri Lanka in the Medan Pitya second pile project actually is a pumping house for the sewage plant. So they want to renew this pumping house. So they build up this shaft, excavation shaft. So let's go to see the project. So it's a project layout. So in totally the pile quantity is 134, 67 number of a primary pile, 67 of secondary pile, diameter 880, pile depth 16 to 21 meter deep, excavation in the center 40 meter. The primary pile 500 millimeter into the fresh rock, secondary pile we need 1 meter key into the fresh rock. So the overcut length 130 mm left and right. So the center to center, the pile center to center will be 750 only. So double O casing, we have several set, and with drilling tools we're using the soil auger, rock bucket, coal barrel. The drilling rigs is a BG30 on ONK base. So this general soil condition from the layer 1, 2, 3, 4. This is all the stuff on layer 4. We go to the completely weathered rock. SPDM value still 20 to 80. Layer 5 already go to the slightly weathered rock. Then layer 6 really fresh rock. They say the strength 50 to 80 MPa. So some highlights to be here. Every corner panel, every corner pile should be a primary pile, because the primary pile drilling left and right is nothing. It's drilling free. But once you put the primary pile left and right, you drilling the corner for the secondary pile. You overcut into the concrete left and right. This concrete will push your primary pile moving out. So have to be very careful when you design this second pile wall. The corner panel must be the primary pile. So this is the design for the guide wall formwork. And our client really clever. They make steel-made formwork. They're using a surveyor to positioning this formwork, concreting. And you see after they dismantle the steel formwork, they're moving forward to next section. It can be recycled, use it. So this is the groundbreaking ceremony in August 2005. So this we connecting a casing. This what I say, we have to check the verticality of the casing during the installation in both X and Y direction to make sure your casing going straight. So for the performance wise, the drill down to the rock surface only need in together with the rock, we need about 3.5 to 4 hours, including the casing connection. So every day we finish 2 piles easily. So this the 1 meter long granite coal taken by the coal barrel at the first secondary pile. I think the rock strength is definitely more than 80 MPa. It can be 100 MPa or even above. Yeah. Then the trimming pipe concreting and casing withdraw by BG38 after concreting work. So this next year in 2006 January, excavation almost done. This is how the nice wall surface after power technician left. Our client still do the work pretty nicely. Okay, this is my part of the piling. I will change over to the diaphragm wall now. to the another topic, diaphragm wall construction. So my agenda here, the diaphragm wall system, diaphragm wall construction, power hydraulic rack, power trench cutter, the joint system, the panel layout. Then last section will be other guide wall, working platform, panelized storage, and handling, reinforcement, installation, and concreting. So the first, diaphragm wall system. So history of the diaphragm wall and the cutter wall. It starts from 1920, the theory from a German professor. The 1950, the first used in cutter wall construction by the company ECOS in Italy. And 1954, using European country as France and Germany. And 56, go to South America. 57, go to Canada. 59, go to Japan and USA. 1971 is used in Taiwan. And after that is almost a standard for the retaining structure. 1980, used in China. 1995, the cutter wall construction for the biggest famous project, China's Three Gorges project, was there. So how to identify the diaphragm wall and cutter wall? Normally the cutter wall is no rebar cage inside. The diaphragm wall will be a structure. We have a rebar cage inside. So this is a different type of a wall. The left-hand side is a typical diaphragm wall for the retaining system. You can see either use the anchor or use the strut. In the center is a cutter wall, because the cutter wall never be excavation out. So it's normally used for the stop the seepage of the hydro dam. So it's inside the ground. You never see that. So we call it the cutter wall. And the right hand side is a shaft wall. If we do in the wrong shaft, normally you don't need any support during the excavation, like an eggshell effect. So this is the concept of a diaphragm wall excavation. So the blue color is the guide wall. The pink color is a rise up and down the panelized level. Inside is the trench, which we excavation down already. Then on the surface of the excavation will be the membrane caused by the filtering bentonite. It will be the same as piling. We balance with our counterweight of the slurry density and also its level. So an advantage of the diaphragm wall is the structure strength is higher. Very stiff structure. The movement compared with other foundation system is quite small. The water tightness, the joint system is pretty good. And less number of the joint per square meter of wall. So this section of diaphragm wall. In this section, you can see a 3 joint. Every panel will be 3 to 7 meter long. So we will go back to the second pile wall. You see the older pile diameter AAT or 1 meter. So you will have a lot of joint. So joint, more joint means you have a more chance to get the leakage. So the effective wall thickness, the diaphragm wall will be the same as its thickness, but the second pile wall will be some concrete will be waste. Yeah, this is what I say. The diaphragm wall thickness equal to the effective wall thickness, and wall depth can above 150 meter. So we'll go to the next section, diaphragm wall construction. For the preparation to start a diaphragm wall or cutter wall, first of all, we need to have additional soil investigation to confirm the ground condition on the the line up of on the line of your diaphragm wall. We need the additional ground investigation to confirm each panel the depth of the diaphragm wall or cutter wall, and also confirm the rock strength if the rock layer encounter. Then we have to select the feasible equipment, construction method, and also the joint system. Then later on, we have to work out the construction plan, organization chart for the equipment, construction sequence. For example, you work in the downtown of the city, you have to consider the road diversion. You don't block the main roll completely in once for 2 years is not nice. So we have to maintain the traffic. So we have to consider the roll diversion, and we have to work out this sequence how to complete the work. Then the treatment of a special difficulty condition which may happen on site, like a very soft soil, we need a very deep guide wall, or the soil improvement for the very soft clay. And the number 3, we have to work out the panel layout and also the grabbing and cutting sequence. Select the suitable excavation system. The left-hand side is a power hydraulic grab, right-hand side is power trench cutter. So again, we put on the top is a soft soil, hard soil, up to hard rock, and also the depths. For the second firewall, as we say, the depths down to 25 meter. Sorry. If we go deeper, we maybe need additional casing oscillator. But for the rock, it go up to 100 MPa. It's no problem for the drilling. For the grab, I think the excavation down to 50 is okay. But further down, the grab can go down to 70, 80 meter, but the performance will reduce because the grab have to up and down every time. Excuse me. So when have certain strengths of the soil to a weak rock, the performance of the grab also will getting reduced. For the cutter, you can see cutter almost cover everything. Only the shallow area, because the cutter is a system working, we need to arrange the pipeline, connecting the pipeline, and also the descending system, every system. So the depths below 15, 20 meter is make no sense to use the cutter, but if the rock is hard, so no choice, you have to go with the cutter system. So we go to the power hydraulic grab. So the typical construction sequence of the grab. So first, we excavation in the primary panel, first bite and the second bite. Then we take out the third bite, the center bite. The number 3, we install the stop end. Number 4, we install the rebar cage and concrete. For next one, we call it successive panel. The first bite will be a little bit outside. The second bite, we clean along the stop end. Then we remove the stop end, install another water stop, and put in back this stop end. Install the rebar cage and concrete. The wall can be connected. We can run in left and right. For the other mechanic grabs still available in the market, they have many brands like Italian Ecos, NCB, Venapachi, or Stein. The difficulty for them is a hard soil, very difficult because they don't have a hydraulic crowd force. The verticality control is another story because you see the mechanic grab on the top, only 2 wire rope, one for up and down, the other one for the close and opening, nothing else. So you need a very experienced operator to handling this mechanic grab. So this power GB working, but the consultant is they used to work with a mechanic grab. So this how they check in the deviation when we drilling, when we excavation. I show the consultant what we can see from the computer is more exactly than this measurement. So this is our power hydraulic grab carrier. We have 3 type of GB, and also the hydraulic grab can mount on our MC crane. So this is the GB carrier, GB40, GB50, and also GB80S. So different size can achieve different depths and also different power, have a different hook load can take. So this data spec, so I don't go through this one. So this is also our hydraulic grab also the winch up and down speed. And you can see we have a turning device TD4, and also for the different kind of GB for the suitable working range. For the GB40, we recommend 600, 800 thickness. GB50 can go up to 1 meter. The GB80S even can go up to 1.8 meter. So this another application. So we have developed this turning device from the left-hand side, the GB3 to TD4 a few years ago. So you can see the size is much smaller. GB3 is the old design with a wire rope with a cylinder pulling left and right to turn the grab. Right-hand side, the TD4 is very simple with hydraulic to turn the grab. So this is the same machine, MC64. Left-hand side, he's using the GB3 grab at that time, the DHGSF. The right-hand side, he upgrade to the VF, a heavy-duty grab with a TD4 turning device. Why we talk about the turning device so important? For the turning device, the grab allowed to work in 90 degree, not only the 0 degree. If we have a confined space, the neighbor building very close, we don't need to cross on the guide wall. We can use simply a turning device to achieve the place we need to dig in. So, and also the grab design, normally one side is 3 teeth, the other side is 2 teeth. When we have a turning device, this cross mark is a blind area for the excavation. With the turning device, we can clean the blind area nicely and can achieve a better performance and better verticality. At least a machine with a GB80S with a turning device and a steering flap. So this is the monitor in the cabin. So we have a status bar, we have a grab position, XY deviation, the depths and every penetration. Number 4 is the menu bar. Number 5 is the inclination reading. So you can see a 0.01 degree moving. Then we have a grab turning angle. And we have operation data. You can see the pressure. And once the pressure up to 300 bar means the grab is fully open or fully closed. Then we have a positioning of the base machine. Then we have a main winch speed and also the hook load. How we calculate this deviation on X and Y? On the grab body, we have an inclinometer installed in the grab body. So we can read this inclinometer by the computer. Then we time with the winch movement. Then we calculate this deviation very precisely. This is how it looks like. Once we have a deviation shown in the cabin, if an operator wants to correct the deviation, he can push the flap individually to push the grab moving out, moving in, or left or right. So the hydraulic grab is a very long body, 8.2 meter long. Will function as a very good guide for the excavation work. The grab control system will help operator to control the excavation verticality very good. Turning device is not only for the working in the corner panel, confined space, and also for the higher performance in the hard soil and the better verticality control. So this is our special grab for the low headroom. You see this machine in Singapore, you're working below a flyover for the deep diaphragm wall. Then we go to our trench cutter system. As we say, the cutter almost covers everything compared with the grab. So this is a typical working sequence of a cutter. We call it overlap cutter joint. Sorry, I come back. The first, we cut the primary panel, first cut, second cut. Then we take out the middle cut, install the rebar cage. We don't have a stop end. Install rebar cage and concreting. We have a 2 primary panel. Then we overcut the concrete left and right in the center. Then we brush the joint, install rebar cage, then we pull the concrete. It's a cutter principle. The cutter wheel turning, we have a fine cut, wheel pumping by the slurry together on the mud pump and go all the way to the descender. The descender will separate the fine cut, like a sand to moving out, and slurry, clean slurry will going back to the trench, like a circulation. So this is a cutter, mud pump. We have a pipeline system. We have a button plant system. Then we have a mixer. So power trench cutter, nowadays we have 5 models available from smaller to the biggest. And also the carrier, we have a many systems from a crane line, can use the HTS hose tensioning system or hose synchronized system on the BG, or even we have a special carrier only for the cutter. So some really deep cutting project. This one I get involved in 2018 in January. This one we reached the 150 meter. It's not the deepest, but it's the deepest overcut joint. Means we overcut left and right the concrete to 150 meter deep. So it's no limit for this joint system. It's 150 meter. Is our guy in a night shift, young engineer, and the Indian operator and the Chinese junior operator. I'm the guy behind the camera. So this really deep is cutting. We reached 251 meter in 2019, September 25. So the picture I took with myself inside as well is in June 17, we finally complete the first cut of 228 meter. It's a record already at that time. So the one cut will be 3.2 meter wide, 1.5 meter thick, and also 228.4 meter deep. So the volume of one cut already almost 1100 meter cube. It's a project for the diamond sampling in Canada. So this we achieved the world record so far, 251 meter, 0.4 in September 25th, 2019. So we have a different cutter wheel can select. The standard cutter wheel, round chisel cutter wheel, and roller bit cutter wheel. So for different kind of soil condition, the standard cutter wheel still can cut into the rock if the rock strength less than 50. For example, our concrete will be 30-40 MPa. If the rock strength are up to 50 or even 60, the standard cutter wheel have a very good chance. Above that, we should consider to change over to the round chisel cutter wheel, or we call the full face cutter wheel. If above 100 MPa, we try to use the roller bit barrel. So for the cutter itself, for the MBC30 and the BC32, we cannot use the roller bit cutter wheel, but the bigger cutter can use all. Cutter control system is actually similar to grab. We have also the inclinometer. The computer can read from the cabin, and we can operate every flap individually by the touch screen to steering the cutter during the cutting. You can see more clear here. The inclinometer reading, then we can control the flap, 12 of them individually. Then we generate the B report. So after we have additional soil investigation, the depth is confirmed. The rock socketing, yes or no, also confirmed. If the yes, you have to consider go to the cutter. Then we have to select the excavation system confirmed. Before we look into panel layout, we still need to look into the joint system. So number 5, the joint system, we highlight here for the CWS joint system, also the overcut joint system. There are many joint systems in the world at this moment. We focusing on the CWS also, and also the overcut joint system. So cutter can use all of them, but the grab cannot use the overcut because overcut is only for the cutter. So this is how the CWS joint look like. You can have one water stop or two water stop. So this is how it look like. Left and right have a CWS joint, a rebar cage, and concrete. So once you go to the next panel, excavation down, remove the CWS joint, but the rubber water stop will remaining in the concrete. So the stop end, in practically, we need to about 60 mm smaller than the excavation thickness. Then we have to remove the CWS joint by this special chisel. And this is the water stop we're using, the robot. You can see it's exposed CWS joint. Is the water stop actually embanked inside the concrete. So this is a power CWS joint system. It's a quick connecting with a coupling and a pin. And we have this stop and removing edge on the bottom of the grab. When we need it, can tail out, go into the groove, can bring out the CWS joint. Then we go to the overlap cutter joint. So typical working sequence, as we explained already, we cut the primary panel, 1, 2, 3 cut, concrete, and we in two primary panel, we overcut in the center. So it's how it look like. The primary panel can be 2.8 meter to 7 meter long. In the center, remaining will be 2.2 meter to 2.6 meter in distance from the end to end. Length, our cut is 2.8 meter. The cutter itself is 2.8 meter cutting. So we will overcut into the left and right, 10 centimeter to 30 centimeter. So advantage, we don't need a stop end. So we don't have a depth limit. As we say, we already prove we can overcut down to the 150 meter and very good water stop capacity. So normally a principle for the cutter operation, left and right should be the same material. The first one is soil. It's like a primary panel cutting. In the center is a concrete, means overlap cutter joint, is a secondary panel cutting. Or right hand side, the slurry means the middle bite of the primary panel. So it's how it look like. Number 1, number 2, number 3 bite. The middle bite, we suggest to remaining the length still be 80 centimeter to 1.2 meter. And also in when we install the rebar cage, we still need a PVC pipe to hold the position of this rebar cage, because during the trimming concrete, the concrete pressure can push the rebar cage to the left or right. So this is how it look like. Yeah, this is how we overcut. And this we overcut down, we pump up the slurry to let you see the zigzag surface of this overcut. This is the joint. I myself climbed down 50 meter deep. It's a joint for the Yellow River diversion project. It's a deep shaft for the 75 meter cutting depth and excavation depth to 51 meter. This is the joint. I took the picture from 50 meter deep, dry, clean, and nice. So once we confirm the joint system, we can work out the panel layout. So the primary panel will be can be a single bite or 3 bite. The cutter the same, can be single cut or 3 cut. If the concrete, it will look like this. On the top is a excavation, 1, 2, 3. For the successive panel, for the cutter and grab, we can use the 3 bite. We can have a left, right, and also the center bite. Yeah. But also we can work with a 2 bite, but this one only for the grab. Grab will work on the bite number 1. And later on here along the stub end, you go down with the grab number 2. And this the closing panel can be 3 bite as well, also 2 bite for the grab only. And for the CWS joint, we recommend all the corner panel has to be how to say, the closing panel. The corner panel has to be a closing panel because once we remove the stub end, we don't need to move it anymore, and we just concrete it. And normally in the corner panel excavation at the corner, normally we will have some collapse happen. Once we collapse too much, and if you have a stub end joint here, your stub end may be remaining in the concrete, cannot take out anymore. So the corner panel, we recommend to use a closing panel. In case the limitation, we still can use as successive, but we try to avoid that. So later on, some other preparation work for the diaphragm wall. For the guide wall construction, is the structure of the guide wall. Because the guide wall for the diaphragm wall, we need to stay stable, and also we need the strength for, we hang a rebar cage, everything on the top of the guide wall, so need to be very strong. That is more detail, and also the picture when the guide wall construction. And this even better, have a nice concrete pavement working platform together with the guide wall. So this in Shanghai project is totally full pavement concrete working platform. So one cutter will be 200 tons at least. So it's very nice for the heavy machine working on the top. This slurry plant is what I built in India. So this is the design of the slurry plant. We have a fresh bentonite, working bentonite, and during the cutting and during the bentonite cleaning, we have the valve open and close, different numbers. We can run this, handle this batching plant nicely. So the capacity of a bentonite slurry storage for the working slurry, we need to be 150% or 200% more than the panel volume. If the fresh bentonite, fresh slurry, we need to 1.2 times to 1.5 times of the panel volume. We need to keep in the storage. And reinforcement installation, the left hand side you can see the primary panel 3 byte, pretty big panel. For the secondary panel, normally 2.8 meter single byte panel. So this is a picture I took 2-3 years ago in Shanghai. They installed a rebar cage. The panel is a 1.2 meter thickness, but 3 by 7 meter long and 78 meter excavation. This only the one section of the rebar cage is about, I think, 45 meter, 50 meter long. So they're using 2 units, 400-ton crane to lift up together. So it's how they lift up. Very impressive. And for the concreting, for the trimmy pipe concrete, normally a trimmy pipe concreting, we say one set of trimmy could cover 1.2 meter to 1.8 meter range left and right. So once your panel less than 3.6 meter, you only need one set of trimmy in the center. So if the panel length between 3.6 to 7.2 meter, you probably need you need 2 sets of a trimmy at least. But this is still subject to the panel thickness or diameter of your trimmy system. For example, you have the panel thickness more than 1.5 meter and your trimmy pipe only 8-inch for the size, so you may need more trimmy pipe. So this in Canada 10 meter long panel, pull the concrete together with 3 trimmy pipe and 3 mixing truck together. So for the concreting, some notice point, we need to make sure we have a sufficient number of trimming pipe. We have to keep the rising speed more than 3 meters per hour. The interruption during the concreting, sometimes we have a late delivery by the mixing truck, but in between cannot more than 30 minutes. Trimming pipe diameter will above 15 centimeter. Normally the typical we're using the 10-inch. Sometimes we're using 12-inch with a watertight coupling. And then the plastic bowl we have to use before the first pulling to avoid the segregation of the concrete mixed with a slurry. Embankment of a trimming pipe minimum 2 meters below the top of rising concrete. The slump of the concrete will above 180 mm. I think that's all for my presentation today. Thank you very much.
Thank you very much, Mr. William Chang, for the fruitful and very interesting presentation. This session is on modern construction practices in board pile, secant pile, and diaphragm wall constructions. This is a two-part lecture series. The first part was on construction, and the second part will be on testing. That session will be conducted by Professor Samanthilakasiri in January 2021, because in December 2020, we do not organize or present a session, a knowledge sharing webinar session. So the next knowledge sharing webinar session will be in January 2021, the second part of the same series. So I think we can very happily say that today's webinar session was one of the a knowledge sharing session with one of the highest participations. I think we had over 280 participants for the session today. I will take this opportunity to thank all the participants to make this participation fruitful for this very vital session. Before we step into the panel discussion, I think Mr. William Chang, today's resource person, due to an urgent concern, he has to leave this session. So before we step into the panel discussion, we would like to handle the Q&A session on the presentation which Mr. William Chang presented today. So in order to conduct the Q&A session briefly, I would like to invite Engineer Nandana Munutudua, the General Manager of Industrial Sales and INSEE Concrete, to handle the brief Q&A session for Mr. William Chang's presentation.
Good evening, Mr. William. Thank you for taking your time. We have to consider that you are 2.5 hours ahead of us, and you have other commitment to fulfill. So just before we go for the panel discussion, I will pick one question which reached to us from the audience. It says pile software is a failure mainly due to pile bottom cleaning. Any advancement technique other than semi-circulation is the question. Can you please take this question, Mr. William?
Yeah, I know there's a normal practice for the descending in Sri Lanka. They're mainly using the circulation of this button blow-in. But somehow in the other place like Malaysia, or even I think Hong Kong is one of the most critical area for this piling business. They need to make sure the zero settlement, then the contractor will get paid for this piling. So they will install a sampling pipe in a rebar cage and close into the button. After pile finish, they will go through this sampling pipe to collect the last part of this the pile concrete and also part of the rock in the button. So the gap, if above 3 mm, they don't get paid. So once you have a settlement more than 3 mm, you don't get paid. But actually, this practice also quite popular in Hong Kong already, and also Malaysia. We're using the airlifting system to pump out the slurry to go through our descender. Then the clean bentonite will go back to the bore pile, right? Then they will have another system. We don't simply descending and go back like a circulation, but somehow we replace the bentonite 100%. For example, we pumping back the working bentonite through the trimming pipe from the button to the descender and go back to storage. In the same time, we pulling back the fresh bentonite. Because the density of the fresh bentonite and the working bentonite will be quite different. The working bentonite can be 1.1 or 1.15, but the fresh bentonite itself only 1.03. For this different density, the fresh bentonite will always on the top of this working bentonite. So once we pumping out the fresh bentonite from the button, means the slurry in the bore pile is totally clean and exchanged. It is what Hong Kong they're doing with this to make sure zero settlement.
Okay, thank you very much, Sen. I think now you have to leave here. So thank you very much again for participating in this one. So now we will head into the panel discussion. Since we were discussing the diaphragm walls in the last session, I will raise this question to Engineer PV3. PV3 is the Deputy General Manager of Piling Division of Access Engineering PLC. So Engineer PV3, this is so to you. Can you explain the difficulties and challenges you faced in introducing entirely new construction technology like diaphragm wall construction to Sri Lanka? So we all know that you completed ITC and some other projects in diaphragm wall. Can you please explain the difficulties in people management and machinery and other testing in diaphragm walls?
Okay, thank you very much, Mr. Nandana. As you said, we have started ITC Colombo 1 project in 2015. That was the first ever diaphragm wall project in Sri Lanka. The very first diaphragm wall project in Sri Lanka. Initially, actually, a client has idea to do a secant pile wall, but considering the price matter, and he has a very short time period to complete the project. Therefore, he proposed us to do a diaphragm wall project. Considering the secant pile wall, one day we can do approximately 1 or 2 piles by a machine. But diaphragm wall method, the advantage is we can do 1 or 2 panels. One panel is about 5 to 6 meters. That means one day we can complete 5 meter or 10 meter in average. Therefore, the client has decided to go diaphragm wall method, and we took the challenge, and we choose our machinery partner as Bauer, and we acquired the machinery and the technology from Bauer to introduce diaphragm wall technology in Sri Lanka in ITC Colombo 1 project. As you explained in the very initial stage during this negotiations, actually it is a huge capital cost for this diaphragm wall technology enhancement. And from the management perspective, actually we have to evaluate the risk of how to find new business opportunities for this diaphragm wall business in Sri Lanka. But after this ITC project, we successfully secured few projects, and we were managed that risk. and we will get very short period to train our people and acquired machinery. Then actually we work with Bauer, and we send our key staff members and to international working sites in China and Malaysia, and we get them trained in that environment, Bauer environment. And technically, as you know, in Sri Lanka, there is a variation in rock, considerable variation in rock, especially in Colombo. Then we have done a thorough geotechnical investigation in ITC project before the panel design. From the geotechnical investigation, we found that some areas, the actual panel depth would be lesser than the design panel depth. That was a major issue we faced in the design time. Then to mitigate that risk, we got some additional precaution for the short piles for the stability of the diaphragm mold. And as Mr. William explained in his presentation, one of the key component in this diaphragm mold technology is managing the bentonite. For one panel, approximately it consumes 100 meter cubes, and if we go for two panels, one day consumption would be 200 meter cubes. So it is a quite large volume. So we manage 350 meter cube bentonite storage daily in our site throughout the construction period. That was a huge challenge. And as Mr. William showed in the latter part of his presentation, handling the reinforcement cage was a quite challenging job, because for the corner panels, it is a very heavy reinforcement cage. Then to mitigate that risk, we deployed higher capacity cranes, 3 number of higher capacity cranes, and we specially designed this reinforcement cage with more stiffness to avoid any deformation. And we add more lifting points, as Mr. William showed in his presentation. Actually, those are the some of the key issues and key challenges we face introducing the diaphragm mold technology to the Sri Lanka.
Yeah, thank you, Vidri. So I would like to ask this question from Engineer Abesinga. So Engineer Abesinga is the Director, Senior Geotechnical Engineer of Pile Test Consultants, and he has, before that, he has vast experience in piling construction as well. So Engineer Abesinga, since you both experience in pile construction and testing, can you please explain the effect of poor construction practices on the final quality of the pile, like not adhering to proper pouring sequence, pipe removal, and not using proper concrete mixes, and etc. etc.
Yes, thank you, Ms. Nandan. Yeah, thank you. Actually, if we come to this diaphragm mold issues, one of major expectation from this diaphragm mold is water tightness. So in that case, facing concrete, it plays a big role. Concrete. So in that case, the concrete actually you have to the mixed design. From the mixed design stage, you have to consider that concrete quality. That means the what is called this slump and pumpability has to be properly designed at the design stage. That means mixed design has to be properly done, and according to the project requirements. So the chemicals, what you call this retarders, accelerators, and what whatever the chemicals you have to put for this concrete has to be very carefully selected. Otherwise, you can't get water tightness of this diaphragm walls. That is one important. And other thing is when you selecting the mixed designs, so you have to consider the hardening time, and you have to check this uh, delay time also. So those are other important factors. And other thing is when you pour in the concrete, the trimmy pipe should be always lower than the concrete top level. Otherwise, the concrete mix will mix with bentonite slurry. So if that happens, so pile low, whatever the panel of the secant pile wall also can be defective. So in that case, during the concrete placing, so you have to be very careful to ensure that always trimmy pipe should be below the concrete, and the quality of the concrete. That means sufficient concrete, as Prithvi explained, should be arrived at the site. Then only you have to start the concrete, and the quality of the concrete, especially if the quality is not good in the mixed designs, so concrete can be segregated and bleeding. So many problems will come. If anything happens, the water tightness will lose, especially for the diaphragm walls. So that is the actually main important thing, I think, when it comes to the concrete placing. And next thing is bentonite also. It also plays a big role, as Dimitri explains. So if the bentonites also will keep for a long time, it reduces drastically the skin frictions. And sometimes if the bentonite keeps more times, so it will make a line in between that in between this wall of the diaphragm or whatever the shaft wall in the pile, so that cake will be collapsed. Then it will mix with the concrete, and it reduce the performance of the pile, so diaphragm wall. So bentonite also play a big role. So that's what I think main issues when you place in the concrete you have to consider. I think good answer.
Yeah. Thank you, Engineer Abhishek. Now I'd like to raise discussion to Engineer Udyanga. He is the director of CSEC. Engineer Udyanga, what I wanted to hear from you is, since you have the experience in working with different piling contractors in different projects, please give an outlook of how different contract agreements affect to the total cost and total construction time of the project is.
Thanks, Randana. I believe everyone can hear me. And good evening to everyone. I would like to thank, first of all, to INSEE arrange this session during this challenging time and keep the momentum going for construction industry and awareing people about this important foundation works. And again, for Bauer to do a great presentation where it memorized all the aspects and the steps for all the people who have participated for this. And I hope all are safe and well. On the question that you have asked from me is that, I mean, basically in Sri Lankan practice, even in other countries, that the main contract and the piling contract is two different contracts. So because why we divide it is to save cost, save time, sometimes to buy time to finalize the superstructure tender or the designs, or to get the specialty work done by the specialist, because the piling work is a specialist work where other general contractors can't do, where it involves specialist equipment, specialist machinery, where it needs specialist knowledge to execute it correctly. So, and when you divide these contracts by keeping the objective of save money or time and make sure that you will gain certain benefits from this. The assumptions, the main assumption is that everything will go correctly. So where we are dealing with below soil where we cannot see, I think in the presentation and other panelists have highlighted correctly, the QA/QC is the most important thing in the filing construction, where our assumptions will give the results that we expected. I mean, from setting out, drilling, base cleaning, concreting, to removal of casing, we have to be fully focused on QA/QC and make our all efforts to make sure that our assumptions have worked properly. Otherwise, this will lead to subsequent problems and it will delay the project and it will increase the cost. And it will lead to so many subsequent problems. I will give you an example. If the piles are not done properly, or if the piles have so many defects, when the main contractor mobilized to the site, we have to address those issues. So then that means during the time of piling, we haven't taken our assumptions correctly and we haven't exercised the proper QA/QC to maintain our assumption in the right direction. So I think that is what I can say briefly on the contract. So make sure that when you divide contracts, the conflict management between the contracts where things has to go correctly, otherwise you will open up so many subsequent problems in future of the same contract or the construction of that project. That's all from me.
Thank you. Yeah. Thank you, Engineer Danga. So now we will move to the questions which is raised by the attendees. So I would like to put this question to Engineer Abesingha. So it's a two-part question. So one is what is the meaning of soft toe and pile necking, and how to check soft toe in wet pile and dry pile?
Yes.
Yeah, basically this is all you.
Yeah, I will answer first question initially. That is what is called how to identify. The question is, first one is, what is mean by?
Sorry, first part is first part is what is the meaning of soft toe and pile necking?
Yeah, actually soft toe mean, so if the concrete, stiffness of the concrete or whatever the pile bearing toe stiffness is less than the stiffness of the concrete, it is called soft toe. For the same rock level, that means if you use a higher grade concrete, so you will get if the rock stiffness is low, you will get a soft toe. At the same time, if you use a similar same rock, if you use a low grade concrete, you will get a hard toe. That means it depends on the quality of the or stiffness of the rock or stiffness of the what is the material what you are placing. It's a relative actually. Relative to the concrete strength. If the rock is weak, it is called soft. Relative to the concrete stiffness, if the rock is hard, it is called hard toe. I think you got. And necking mean actually reduction of the cross-sectional area. So soft toe and hard toe is actually, it's a new words when piles are terminated on soft rock or hard rock. So I think depending on the rock conditions, you will get both soft toe and hard toe conditions for a same project. Got the point? And other question is, other question, Mr. Nandana?
Yeah, other question is how to check soft toe in wet piles and dry piles.
Yeah, as I explained you above, whatever the drilling method is called dry methods mean without bentonite. So and wet mean with bentonite or slurry. So either wet or dry method. So initially you can't identify soft or hard. Once you do the testing only, you can identify pile whether the pile has soft toe conditions or hard toe conditions. So before doing the pile, so you can't tell that the pile may have soft toe conditions or hard toe conditions, because as I explained you, it depends on the stiffness of the concrete or stiffness of the rock compared to the resting material or the above material. With the point?
Okay.
So that's
Yeah,
how soft
thank
toe and hard
you,
toe is defined. So actually soft toe and hard toe, whatever
Okay.
you get soft toe or hard toe, it is not actually defect. So it is a condition of pile. So you have to compare the piles with the other piles also. If you get one pile on the project's soft toe condition, so that means it has the reduced capacity. That means the stiffness of the bearing layer is somewhat weak than other piles. So it doesn't indicate that pile is defective, but it is an indication of that some sort of poor quality. Good. That's
Okay.
the soft toe and hard toe condition.
Yeah, thank you, Engineer Basinger. So the Engineer Udanga, this is for you. Actually, you have answered the similar kind of a question in Q&A also. I will like to raise it again for the benefit of the audience. What are the special locations that secant pile method is used?
Yes, Nandan, I think I have answered that in the Q&A session during the presentation. Basically, where the water tightness of the excavation is paramount, and where there are nearby buildings which are settlement prone, or utilities like electrical cables, old gas lines. So, I mean, then we have to decide from the inception that what kind of retaining wall system that we are going to do. And when you do excavation below the water table, where the water table is high, where you foresee that there will be water leaks, sediment leaks, and there can be settlements. So yes, I mean, on that occasions, we have to use secant piles. Another example is if you have very sandy soil, and if you are digging below the water table, better advisable to use secant pile system to make sure that unobstructed construction, the basement construction, can carry out.
Okay, thank you, Engineer. This Engineer P3, this question is for you. What could be the best practice to come bentonite cake form cake? Suppose the concreting is delayed after boring for few days.
Yeah, best thing is to concrete the pile just after the excavation, Engineer Nandana. And if the concreting is get delayed, best thing is to clean the pile again with the boring rig, with the cleaning bucket attached to the boring rig. And then we can either flush the pile or we can suck the, we can use the suction method to clean the pile toe, and we can continue the process until the sample obtained from the bentonite sample obtained from the pile attain to the satisfactory level. I mean, to come within the specific limits. Then we can ensure the pile is good for concrete.
Okay.
In addition, if the sand content and the density of the pile, density of the bentonite inside the pile attain to the satisfactory level, we can go for concrete.
Yeah, thank you, Vidri. Now there are two similar questions about the secant control secondary pile. So are these secondary piles also load bearing? You get the question. Would you consider the primary piles as load bearing and the secondary pile as supporting the primary piles, secant piles only, the seal between the primary piles with no significance as primary piles?
It is depend on the structural. It is depend on the structural design, Mr. Nandan. I think our Chang can answer that question.
Yeah.
Okay.
The question is, are secondary piles also load bearing?
Normally in retaining walls we don't, but in few of the projects I have seen where the primary piles, that is the hard pile, where you have the reinforcement are utilized and socketed to the rock, will be used to support the column loads, but not the secondary piles, because secondary piles are basically grade 15 or grade 20 piles, where its primary use to retain the soil. But there will be certain capacity, but it is very less. Normally we don't use. That is only for primarily for retaining the earth during the excavation.
Okay, thank you, Engineer.
Okay, I think we have come to the end of the panel discussion. Let me thank you, Engineer Udayang Alves, Director of Civil and Structural Engineering Consultants Private Limited, and also Engineer R.M. Abesingha, Director, Senior Geotechnical Engineer of Pile Test Consultants Private Limited, and also our friend Engineer Pivithiri Jayasinghe, Deputy General Manager of Access Engineering PLC. Most importantly, I think we had the most appropriate and suitable moderator today, who has the experience in piling, especially from the suppliers element. Engineer Nandan Amunuthuduwa, General Manager for Industrial Sales and INSI Concrete. So, ladies and gentlemen, we have come to the end of this session, very fruitful session. The main session was conducted by Mr. William Chang on modern construction practices in board pile, secant pile, and diaphragm wall constructions. So this was organized by Innovation to Industry, I2I of INSI Cement, as an INSI I2I collaboration space initiative. INSI Cement, the theme is based on Built for Life. So I think throughout the time period, we have successfully tried to share the knowledge through our 21st knowledge sharing session. Dr. Moza Balbaki, Head of Products and Solutions Portfolio for INSI Cement. Dr. Moza, over to you to give the vote of thanks of today's knowledge sharing webinar session.
Good evening, everybody. Good evening, everybody. First of all, I would like to really begin to thank everyone who attended this November webinar. Despite not being able to really meet in person as we did it before our March starting the COVID, you know, it was really an absolute pleasure to welcome so many of you to this webinar. Therefore, we had nearly more than 300 attendees across the island and from abroad also. And together we are really learning, I would say, the new world of delivering a technical session virtually. I would like to really express my gratitude for the very hard work delivered in this event, especially to our guest speaker, Mr. William Chang, who gave us a very good overview about our technique for the pile underground construction. It was a very generous presentation with a lot of experience. That was great. Also, I would like really to thank our distinguished panelists, Engineer Alvis, Engineer Adisinghe, Engineer Jayasinghe, for your really outstanding somehow experience in this field, and we can show it really on the answer you have gave. Huh? That is, thank you so much. And also, I would like really to thank my my colleague from the commercial and marketing somehow INSEE to support organize this online session. And since somehow March, this is session number 6 in terms of webinar. And I pray God that very soon, next year, we'll be able again to meet, as I said, face to face here at our Paliagoda Eye-to-Eye collaboration space. We have heard really a very positive and encouraging feedback from the last session, and I'm very somehow very happy and pleased with my colleague that this event largely runs smoothly without major technical problems, especially now we have the guests also from abroad. Therefore, as the end of the year approaches, we really begin to look forward to next year. As Dishan said that we have already set our I say topic for January about the testing on fall, and we are also looking forward for very exciting somehow topics from the academia, from our stakeholder, our partner in the industry. We are really looking forward for that. Therefore, as a last word, I would like really to hope you that you stay safe with your family, and wish you very good health with all of you and your friends. Thank you so much, and really God bless our Sri Lanka. Thank you.
Thank you, Dr. Moza Balbaki, Head of Products and Solution Portfolio for INSEE Cement. INSEE Cement, built for life. INSEE Eye-to-Eye, innovation to industry, will reach you again in January 2021 in the new year with its next knowledge sharing session. So thank you very much, ladies and gentlemen, for participating to INSEE Eye-to-Eye knowledge sharing webinar session and the panel discussion for November 2020. We will meet you again with the 22nd successful knowledge sharing session in January. Until that, be safe and be healthy. Thank you. Good night.
Thank you. Thank you. Thank you.